All right. Hello, everyone, and thank you so much for joining us today on this Wednesday morning or afternoon, depending on where you're at. My name is Deborah Sampier. I'm the CEO and co-founder of Hawk Networks, and Hawk Networks is the company that developed all of the IP for the Althea platform, for both Althea L1, Gravity Bridge, and also all of the telecom stack that's available with it as well. I'm excited to introduce you today to Christian Borst, the lead blockchain engineer. So a lot of the code and design behind what is liquid infrastructure is Christian's design, and I think he's pretty excited to share with you about how then you use the tooling that helps you integrate things like liquid infrastructure or other Althea L1 tooling onto a website today. So if you are involved in the hackathon, please join us in Discord. We have a hackathon group there. So if you have questions about building, you can always find us there. For this webinar, feel free to drop questions in the YouTube chat or LinkedIn or however you're joining us today. Feel free to drop those questions in there. We'd be happy to get those answered as we're going along. This can be an interactive seminar. So without further ado, Christian, if you'd like to introduce yourself and kick us off, I'm excited to learn.
Yeah, thank you very much, Deborah. So like Deborah mentioned, I am Christian. I am the lead blockchain engineer for Hawk Networks. So all of my responsibilities are blockchain based. I do a lot of work on Althea L1 and liquid infrastructure. And I do a lot of work on maintaining and improving Gravity Bridge as well. So I am wholly focused on sort of back end like blockchain development. So I'm going to be leading a web application uh, library workshop today. So please excuse me that I'm not a front end engineer. I'm not very well versed in design or UX or a lot of the things involving JavaScript and TypeScript. But what I do know, I will share with you, and these things will work for interacting with Althea L1 or Gravity Bridge from your web application. So essentially what we're going to be doing in this workshop is going through this iFi hackathon Altheajs repo that I created on the AltheaNet GitHub. And so this is going to be a really simple web application, and it's just going to have the minimal information to get your website working with the Althea L1 blockchain. So we're not going to be doing a lot with error handling or user experience or UI design. You'll notice that the website, when we eventually get to that, it's not going to be that pretty, but it's going to work. So this is the repo here. And so if you want to go ahead and clone this on your own after the workshop, it should work out for you. It's just a very minimal web application. If you don't want to clone this repo and base your website off of that, but you still want to use React as your framework, here are the steps that I took to create this repository. And so it's got a few gotchas in there. I'm using the create React app script to set up my project, and that has some annoying things that you need to fix. So we're using React app rewired to fix those so that we can interact with cryptography packages from React. And so, yeah, if you don't care to follow these instructions, just go ahead and clone the repo, and you should be able to do everything that you want to with React from that repo, and you won't have to worry about these instructions. But this is for people who don't want to do that. And then down here, I also have the dependencies that we use for this workshop. This one's not that important if you're more well-versed in UI design, but these AltheaNet packages and the Ethers project packages are going to be critical for it. So what we're going to be talking about here, though, is using the Altheajs package to interact with the Althea L1 blockchain. So Altheajs here, also on the AltheaNet GitHub, is sort of a library that does TypeScript and JavaScript based interaction with Althea L1. And the main focus of it is going to be enabling users to sign transactions with an Ethereum wallet like MetaMask and submit them to the Althea L1 blockchain. Now, this is very unique to Cosmos SDK chains. Althea L1 is part of the Cosmos ecosystem, but it also has an Ethereum virtual machine inside of it. And so this library is going to be critical for letting users interact with MetaMask. Traditionally, in the Cosmos space, users are required to use the Kepler wallet or another Cosmos wallet, but most users have, like in the crypto ecosystem, they work with MetaMask. And so setting up keys and doing all that headache for another wallet is a pretty high burden. So adding this functionality to your website is going to make them a lot more likely to actually be a user. So here we've got some instructions and stuff. We're not going to be going through that just yet, but this is a critical part of interacting with Althea L1. So without further ado, I'm going to go ahead and open a terminal, and just in this iFi hackathon Altheajs repo, I'm going to run npm start. And then in the meantime, I'm going to walk you through what this project actually looks like. So here I've got VS Code open. And so my local copy of the iFi hackathon workshop Altheajs repo is called Hackathon Project here. And so this should be roughly the exact same as what you'd get as if you did a git clone, where you download the files and then you open them in VS Code. So this repo is pretty small. I'll show you the whole structure here. So we've got our package JSON. Notice that we're using React app rewired here. You can find that in the README, but we only have these dependencies, the necessary Althea ones, the Ethers project ones I mentioned, and then everything else is pretty standard. As far as the React app rewired goes, if you are going to follow the instructions, you need to have this config overrides file in the root of the repo. That'll go ahead and alleviate a lot of headaches where things won't compile for you. But we're going to have a pretty simple website here. I'm not going to dive into the public folder because I'm not really using these resources very much. But we've got the source folder has the bulk of our application logic. So, or actually, it contains everything in our application logic. So after running npm start, I had this website open automatically on my default browser. And so this is what the website looks like. I'm just going to give you a demo real quick of what it does. It's a website with the logo. One second. Just had to clear my throat there. So it's got the Althea L1 logo. You can go ahead and replace this with whatever you want. We've got the one tab here that says Bank Send, which is going to enable our users to do a standard transfer on the Cosmos SDK ecosystem of moving funds from one bank account to another. And so then finally, the only thing we have to start for interaction is this Connect MetaMask button. So I'm going to show you real quick. I have MetaMask installed and pinned up here on Firefox, and I've got this account called Account 3. It's already set up with 100 Althea on the AltheaNet testnet, or the Althea L1 testnet. And so it got some basic functionality, like I can do a EVM wallet to EVM wallet transfer through MetaMask itself, and that will behave the same way that this bank send will, but it's going to work in a different fashion. And so, yeah, you can just see here that I've got a little bit. And then MetaMask, if you're not familiar, is a multi-EVM network wallet. So here I've got the Althea Live testnet, but I also have one set up for like a local testnet if I'm running it on my laptop directly, and it just points to localhost. But typically users are going to use Ethereum mainnet. So what you'll want to do for a website if you're going to run this in production is set up, MetaMask has an interface that you can use from your website to ask it to switch networks. You can add a network. You would do something like set up the Althea testnet and have that be the network that you ask them to connect to. And then whatever their default account that they have selected right now is, that's going to be the one that you get returned from MetaMask. So we're going to go ahead and click this Connect MetaMask button. And I've already approved this. So let me go ahead and open this in another window. Opening it in like Firefox's private method will enable you to do that. Oh, okay. So I have an error here. MetaMask is not enabled. I'm not going to go, I'm going to not do this then because that's going to be problematic. So, um,
Live demos, folks.
yeah, so typically what would happen is if you don't have this already connected, is the user would get a pop-up and it'll just say, connect this account to the website and this network. And the user go ahead and says yes, and then your website gets control again and it resumes here. And so what we've got is a little bit of account information. Notice this is not very nicely presented. I'm not a UI designer, but it works. So then MetaMask doesn't present the user's pub key, and we need that for sending transactions to the blockchain. So what we're going to go ahead and do is have a verify pub key function. This is going to prompt the user to sign a message. It just says verify public key. It's not going to do anything like transfer funds around. It's not a valid transaction on the blockchain, and we're not going to be submitting it to any blockchains at all. But we need the user to sign it. And then due to the niceties of elliptic curve keys, we can do a recovery method to get their public key. And so you can see here, we've got their verified public key displayed in base64 format, which is what the Cosmos blockchain will require. And then we've got a whole bunch of input fields that popped up for submitting a bank transaction to send money. So what I'm going to go ahead and do is just copy my own Althea1 account address. I'm going to put that in the to field. And so then I'm going to use a memo test, and then I'm going to just send a tiny amount. This is not 100 Althea. This is like 100 Atto Althea, which is like 100 times like Althea tokens have like 18 decimal points of precision. So this is 100 of those negative 10 to the 18th or 10 to the negative 18th tokens. And I'm just going to submit a fee of 0 for now. And so we're going to hit submit transaction, and it pops up with MetaMask. And so this is the unique part of what Altheajs does for your website. This is going to submit. Typically, if you were going to do a standard transaction using MetaMask, you would have them sign a hash of the transaction you actually want them to submit, which isn't very user friendly. And also people can't really trust it because you could have generated anything with your website, had them sign it, and now they're giving complete control over to your website. What this does is it presents all the information to the user in a secure way so that they can verify like everything that they're doing is correct. So is this their account number? Maybe they know that, maybe they don't. That's kind of an esoteric thing, but they can verify like the chain ID is correct and that they've approved a certain amount of a fee. Right now they've approved 0 Althea tokens. And then some of the other information in here is a bit unrelated to the user, but it's necessary to present. We've got our memo in there. We've got that we're submitting a message send. Maybe they'll know what that is, but probably not. At least this should look familiar. They're submitting an amount and they're sending it from their address to another address. And so we can go ahead and sign that. And this website doesn't present the information after the user submits the transaction. That's a little bit trickier, involves parsing some JSON. But we can see here that we are broadcasting this transaction in the console. Maybe I can make this bigger. Yeah. And we actually got a response that it timed out waiting for the transaction to be included in a block. So we don't know that the transaction worked correctly, but what I can do in MetaMask is just open it up And at some point, I should see that I have a tiny amount less of Althea if the transaction went through. Your website in production would probably send a transaction that has like better handling and might point to a block explorer. So I'm going to go ahead and increase the fee amount to 100 and see if that works for us. It looks like the transaction didn't get included in a block. All right, so this time we got a transaction hash back, but we also got an error. So the sequence is incorrect. So that's an issue with my website. I'm just going to refresh real quick and run through the same steps. Okay, so we're going to go ahead and copy this to test 2. We're going to put in 100 and 100. We're going to submit that, open the console back up. Oh, don't want to open it on MetaMask. Forgot I have to sign it. All right, and if you, I went pretty quick there, but it did say sequences 2, so that should fix our error. Um,
While he's working through that, I know sometimes when the stream comes through on YouTube or LinkedIn, it can look a little bit blurry or not completely rendered. So if you are watching this live, and we'll have the video, of course, available on YouTube after this, or that'll have a higher definition. So if you need to go back through and be able to see the screen a little bit more clearly, don't worry. It'll be available, as well as kind of the links also in our Discord. So please join us there, and they'll have all the links to get to where you need to on this.
Thanks a lot. So what I'm doing right now is I noticed that the transactions aren't necessarily being included in the blockchain. So I'm going to go ahead and query the blockchain directly from the command line, which is what I'm most familiar with. And so we're just going to see what the balances of this account are. So I'm going to do Althea. We need to specify the node, which is, you'll see this later, but it's https althea.zone. And then the port we're going to hit is 26657. We're going to query the bank module. We're going to get the balances of this account. And it looks like at least one of my transactions went through because I am missing precisely 100 Addo Althea. So like I mentioned, this is a number with 18 decimals of precision. And so this is just a lot of nines, but at some point, MetaMask should reflect my balance. It might just be that it doesn't want to show the little tiny amounts off. But anyway, it looks like the transaction did get included in the blockchain. So I'm going to go ahead and move on to the actual code demonstration for you. And so if we have any questions, this would be a great time to address some of those as we get started here with the code. I'm not seeing anything in the StreamYard itself. Do you know if we have any questions in Discord or on YouTube, Deborah?
Right now, we appreciate that pause. It doesn't look like we have any questions for the live audience here. So I would, again, kind of expect that folks might have follow-on questions that would be in Discord. So we'll definitely, you can find Christian, myself, Justin, and the rest of the team available there if you have any questions.
All right, perfect. Thank you. So we're just going to go ahead and move on then to going through the project structure. So this is, like I mentioned, just a small React-based web app. And so in traditional React structure, we've got our index.js that just renders our app. So I'm going to open app.js. And this has a little bit of stuff. We've got an app logo here in the main body of the application. And then we've got this tabs component, which is something that I constructed based on something that I found online. So we can find that the import is pointing to the components tabs file. So I'm just going to open that real quick. And this is a pretty small file. Like it's 42 lines. It consists of just this definition of a tab, which is a type of button that has a parameter called selected that changes the way that it renders. And then the important things for you to note are that we've got this types field here that right now just has bank send. So if we go back to the web application, you can see it says bank send right there. Here's our tab. And in this tabs React component, we've got one piece of state that's called active. And so when a user clicks on a tab, we update active. So on click, set active to the type that we get in. And so that should be one of these. And then down here in the rendering code, we're going to check the active value against the types array here. So we've got it pointing to the first one. And if they've selected bank send, then we're going to render this submit message send component. So this is where things get actually interesting. This is a much larger file, still not that big, all things considered. It's 153 lines, and plenty of it is React boilerplate. So I'm going to go ahead and close the project structure, kind of walk you through some of these things. So let's go ahead and turn word wrap on. Let's see if I can find that real quick. Oh, it's down here. All right, and so that just made it so that these comments that I put at the end of the line are now visible. So this is a single component file. It has a default component called submit message send. So when people import it, this is what they're going to get. And it's got a bunch of different fields. So we've got MetaMask connected, the chain ID, the Cosmos chain ID, fee, gas, memo, to, amount, account info, and cur pub key. So plenty of these things are actually the fields that the user inputs directly, but some of them are fields that we generate on button clicks. So when we hit connect MetaMask, when we hit verify public key, um, and when we get user or the value returned from MetaMask after the user interacts with the browser extension, like when they click sign and connect, we'll get values out. And so this is just how React works. We're going to use this use state function to generate variables and an update function. So if you're not too familiar with React, this is pretty standard. It's nothing complicated. If you're using a different web framework, you really just need a way to set variables. And so that's how this is done in React. And so we're going to be walking through how to build a new component to do a different transaction type. This only handles a bank message send. We're going to be walking through one of the microtransaction message types so that you can submit different types of transactions to the blockchain, and it should offer a pretty good introduction on how to actually go about doing that using this website as a framework. And so I'm not going to go too into detail on everything that we need here because we'll cover it later. But we've got this on submit button, which is what is hooked up to when they hit submit TX. And so that's going to create a transaction, then have the user sign it, then have the user broadcast it to the blockchain. And then this function on connect MetaMask happens when they hit the connect MetaMask button. So I'm just going to refresh this here. Connect MetaMask. It uses our MetaMask service. So we have nicely separated functions here. That's going to involve metamask.js here in the services folder. And so we're going to do a bunch of functions, and then we're going to update the account information. That's just some state we store. We've got a similar function for when they verify their public key. So we're going to set the current public key with the value that our service contains. That's going to involve the MetaMask service as well. This fetch account info is going to use the account info service. And so we'll be getting to that later, but this is just some stuff to update values based on when they actually sign the transaction. We generate something, and then we query the blockchain for more necessary information like the account number, the sequence, and their address. And then here's the real meat of the component. So this is what actually renders. So here we've got an error, MetaMask is not installed. That only renders when our MetaMask installed value comes back false from the MetaMask service. We've got a few other fields that only render if, for example, MetaMask is not connected. We're going to render a button that says connect MetaMask. That's this one. And then that disappears once they connect their MetaMask. So then when the MetaMask account is connected, but we don't know their current public key, we render this verify public key. And so when you click that, it hasn't disappeared yet because we don't know the public key, but when they hit sign, we get the value back. And so everything updates and we don't see that button anymore. And then when we know their current public key, we display it. When we know their account info, we display some of that stuff. We actually convert their account to a Ethermint account or an Ethereum account. So that's what this is here. This Althea1 is the Althea1 address is the standard address format for Althea accounts, but then it's also an EVM. So this is what the address looks like, and that should reflect what MetaMask actually has here. It's BF6131FE, so that does match. And then the rest here are the fields. It's like a simple form to collect user input. So we want the chain ID, the Cosmos chain ID, which is similar but different, gas, memo to amount, fee, and then we finally render the button. And so that's this submit TX button. So hopefully that's not too complicated for you. This is just React hooking things together. So now I want to go into the actual services that do the meat and potatoes of like how the website works. This is going to be everything that you need to use if you're using a different web framework. You'll still need to have this main base of the project here. So we've got one constant here in the constants folder. It is just the node URL. So I pointed to that earlier with a different port when I queried the blockchain via the command line. And then here's our first service, the account info service, pretty simple. So we've got this request type, and I just included these options here for clarity. Here's a headache I ran into. If you try and request with no cores, it breaks if the website actually supports cores. So that's annoying. But what we really want here is this get account info. And so this is going to use the Altheajs library here, the AltheaNet provider package to hit the correct URL. So we're going to go to this definition. Since it's TypeScript, we have to go to a different file. It's going to hit the Cosmos auth v1 beta 1 accounts and then like the actual user input. So that's the endpoint that we're querying for account info. And so in our command or in our console, we should see output that looks like that. Yep, we've got querying the full URL with my account address. And so then, yeah, this function just fetches that with all the options, and then it returns the JSON formatted response. That's the entire account info service. So yeah, if we have any questions on that or anything I've already covered, now would be a great time. I'm going to go ahead and let you interrupt me if you have any questions, and I'm just going to keep moving on to get to the other services. The next service I want to talk about is the MetaMask one. So this one's actually quite a bit longer. It's only 90 lines of code, but still it's dealing with a lot more stuff. So the first thing that we do is we set up some variables. We're going to hold the accounts that are returned by MetaMask. Even if the user has only selected one account at the moment, and we're only ever going to interact with one account, MetaMask returns an entire array of accounts. What's important is the first one in the array is the one we want. That's the one they've currently selected. And then we also have a variable to store their public key. This is another just an annoying thing because MetaMask doesn't let us query the public key directly. We need to have that message that they sign that says verify public key. So that's where we store this constant. And then we've got a bunch of helper functions that you should have seen in the submit message send component, but we're going to run through them here. So MetaMask installed. This just does a simple check to see if the browser has the MetaMask extension available and enabled. If it's not, we're just going to display an error. This connect MetaMask function actually requests all of the user's accounts. Like I mentioned, we're going to get an entire array of accounts, but they used to have a function called connect or like enable, and so that's where this kind of language comes from. But we're requesting their accounts. This is the actual method that we're requesting from them. And then we log all of the accounts that we get back. So back here, we should see, yeah, we've got 3 accounts with just their addresses here. So this first one is the one I'm using. You can see that right here. It's all uppercase, but it's the same string. And so that's what we're expecting back from MetaMask. And we don't care about these other 2 because they're not using those. So moving on, we have the verify pub key method. So this is going to request them to sign our verify pub key message as in the actual account that we want them to sign it with. And I'm not sure what this third param is. I think that's just more options available for specific types of signing. And then we're going to use this recover public key function. This is really helpful. So this is part of the Ethers project, and this deals with the elliptic curve digital signing algorithm. So it's going to take a signature and the input message. So we hash the verify public key string, and then we take their signature that we got back from the user, and we can use that to recover their uncompressed public key. And then what we're going to be using later is actually their compressed public key. So we go ahead and compress that. And then what the blockchain is expecting is not to have a 0x in front of it. So we can see here we've got the public key in base 64 format. We're going to convert that to base 64, but we need to make sure we don't have the 0x in there or it'll mess up our output public key. And then we just set it to that variable that I set up here. Okay. And so when the user, when the form needs the public key, we just fetch the cached version here in this get cur pub key method. So this will fail if they haven't verified their public key. So that's on you to get your flow control right to make sure they can't request this when it's undefined. And then similarly for the get cur account, we're just going to return the cached version here. If it doesn't exist, we're going to return undefined. And so all these the if else is just to prevent like a panic. And then we're not going to talk about signing just yet. So we're going to go back to submit message send, and this would be another great opportunity to pause for questions. If you have anything, I think I just covered a lot of stuff, but I'm going to go back to this on submit method if there are no more, if there are no questions.
Yeah, it doesn't look like any questions. We do have a thank you saying the tutorial is awesome. Thank you for walking through how to set up transactions with MetaMask. So great job. I think everyone's appreciating it, and probably will spend some time going back through the recorded version. So thanks so much, Christian. Please continue.
Thank you for that comment. I'm really happy to hear that this is helpful. I know setting up the library to actually accept these transactions and setting up even this example website to get everything working was like a huge effort. So I'm really glad to just be able to share this information so other people don't have to go through that same headache, or at least not as much of a headache as I did. Just if you have any questions on it or you need more context or anything, please just contact me through Discord, or I think we have a few other methods. Yeah, the Gravity Bridge or the Althea L1 Discord. You can at me on there, and I'd be happy to answer any of your questions. So this on submit method is the core of what we're doing with this entire website. So at this point, we have all of these values stored that should be set up correctly. And so when they hit the submit TX button down there, what we're going to do first is format all of the input, and you can see this is a lot of stuff. We're going to format all of the input that we have from both like the user input and then also the query that we made to the blockchain to get their account info. We need their sequence to avoid replay attacks, and their account number again to avoid issues with like people having certain collisions, their public key, all this other information specific to the transaction, and we're going to format that into what we're expecting for the message. So I'm going to go down to that method here. And this would be a little bit clearer if we had TypeScript enabled, but I had a lot of difficulty getting TypeScript to work with React. So that's not in this project, but you can certainly do it with plenty of web frameworks, and I'm sure somebody knows how to get TypeScript to work. But basically, what we're going to be doing is implementing the following interfaces. So I'm going to go over to the Altheajs code, and I'm going to dive into one of the packages. So this is the transactions package. It's got a bunch of helper methods for generating transactions that are signable by MetaMask and then submittable to the blockchain. And so we're going to go down here into the messages folder and the bank send function. And so what we're actually going to be doing is calling this create TX message send. So we should see this. If I go back here, I'm going to save that one open, and then I'm going to open this one too. So if we go back down here, we're calling that function from the Althea net transactions package. And we're passing in this TX context and the params variable. So let's see what we're actually expecting. We're expecting this context, which if I hit F12, it should take us to the definition. It's just some information about the chain, the sender, the fee that they're providing, and the memo. And then we've got these params. And so this method is special. It takes either a single or multiple values of this type. And so this is what actually defines the transaction that we're going to be sending, the bank message send transaction. And so this is a pretty simple interface. It's just got the destination address, the amount we're sending, and the token we're sending. All right, and so what we're going to be doing here is just collecting all the things. So first we define the sender. The sender is pretty simple. It's just the account address. This has to be the Althea 1 based account address. It can't be that Ethereum account address. Their current sequence, which we queried for earlier, their account number, again, we queried for that, and the pub key we got back from MetaMask, and we derived it and formatted it into base 64. And that was in the MetaMask service. And then here I wanted to be able to provide a default value for the fee in case the user didn't know what to provide. This is a pretty small amount of Althea. And then it's also got the gas included. So if we've collected a value specific from the user and we submit it, we're going to use that. Otherwise, we're going to use the default amount. And then similarly for the gas amount, if the user provided that, we either use that or the default. And so that's why when we open this, React gets this default value here and here. So that's an easy way to set that up. And so what we're going to be doing from there is create the chain. So the chain is, I'm going to separate this into multiple lines since it's smaller now. Oops. So the chain has the chain ID, which is the EVM chain ID. If we go here, it's this 417834, and then the Cosmos chain ID is the Althea underscore that hyphen 3. And so you can query the blockchain for that. I just chose to hard code it here for convenience. And then we're going to form the transaction context, which puts the chain, the sender, the fee, and the memo together. And then we're going to create the params necessary to form the message. So we've got destination, address, amount, and denom. We pass it to the create TX message send, and we return the output here. Along with, we're going to reuse this TX context variable later. So we just return the transaction with that. So all of this is to set up everything that we need to call this create TX message send. It created the context and the params that we send to this function. Out of this function, we get a transaction payload. So hopefully we can see this here. Yep, it's going to return this sign direct value we don't need, but we're going to be using EIP to sign and legacy amino. And so if we go back up here to the onSubmit function, after the user clicks the submit button, we format all that stuff in that method I just explained, and then we're going to go to this sign EIP 712 Cosmos TX. So this is what actually calls MetaMask to sign the transaction that we've just formatted. So we're going to be converting the user's address into a EVM address that MetaMask uses. And we're going to call this very special sign type data v4 method with MetaMask. And what we're going to be doing is using that transaction's EIP to sign as a JSON string and passing that in along with the actual account that the user is going to be signing with. We wait for it to be signed by the user. And then what's important here is we need to pack this signature into a very specific type of signature. So normally on Cosmos transactions, you put it in the signature field. We're not doing that here. For EIP 712, which is the MetaMask signatures, as of the current moment, we need to pack it into a Web3 extension option for the transaction. You don't really need to worry about what that is, but you need to put this code in your front end logic to pack it in there, and then we're putting that on the legacy amino thing that I mentioned earlier. It also had the sign direct. We're not using that. We're just using legacy amino. We're going to put it on the body, and then we're also going to pack the auth info, both of those to binary, and we pass those to create tx raw. So that's another function here in the transactions package, I believe. So we're going to go back down here to the tx raw function. Oh, no, that's not where it is. Let's see, I think it should be here.
All right, Christian, while you're looking for that, we're going to go ahead and do a quick transition here, and I'm going to let Justin jump in and do the latter half of this presentation, if that's all right with you.
Yeah, sure, that's fine with me.
All right, so let me add into the stream here, and Justin, just for quick introduction, is the co-founder and CTO of Hawk Networks. As we said earlier, that is the corporation that developed the IP behind Althea platform. And I'm going to go ahead and leave you in both of these capable hands here to give you a bit more technical direction for the latter half of the call. Thanks so much.
Thanks a lot, Deborah.
Okay.
See you, Deborah.
Hello, Justin.
Hey, hope you're doing well.
Doing pretty well. I think so far the demonstration is going pretty well. Did you have anything you wanted to bring up as you enter in here?
Not particularly.
Okay,
This is looking pretty good so far. Fairly straightforward to use and generate transactions and all of that.
Great, thanks a lot. So moving forward, I'm going to go into this broadcast function. So we just got the user to sign the transaction. We pack it into the transaction type that the blockchain expects. And then we have to jump back out to the component that we're working with. We're going to go into the broadcast function. Here we're going to be just generating the endpoint that we need to broadcast it to here. And the actual post contents are going to look like this. You can call this generate post body broadcast with one of the broadcast modes. So this is using the block option. That'll wait for the transaction to get included in a block. You can also use sync and async. These two aren't going to do anything very nice for you. It'll just return the expected transaction hash. This is the one that actually waits. So I like to wait for it, but it's not guaranteed to work, as we saw earlier. So usually, though, it will return within like 30 seconds. Your transaction got included in the block. So we generate the post content, the transaction body, or the request body. We're going to generate the endpoint, which is going to use that Althea zone 1317 endpoint, and it's going to generate the actual endpoint that we hit, the URL, which is going to be Cosmos TX v1 beta 1 transactions, and then we just wait for that to be sent out. So we fetch, and then we log it, and then we wait for the JSON return. So that's how you actually submit the transaction to the blockchain. I'm going to go into now how we would create a new tab and create a new component to send one of the liquid infrastructure message types, the message liquefy. So we're back in the tabs component. And so here I'm just going to work on adding another one. I'm going to say microtx liquefy. And then down here, since we have a new type, I'm going to just check if we have that one selected. Then I'm going to use a new component that doesn't exist yet. So that's going to be the submit message microtx component. We don't have that yet, but I'm going to just stub it in from a file that doesn't exist yet. So save that. Then I'm going to copy this component that we already have, and we're going to be making basically a simpler version of it that works with a different message type. So this, I think I named that incorrectly. Liquefy. And down here, I did the wrong thing again. Liquefy. All right. Now let's rename this file, submit message liquefy. And here I'm going to basically just comment out most of it. And I'm going to zoom out real quick just so I can view more things and copy pretty much everything, but delete a bunch of it. All right, so here I'm going to define the new component. And we don't need all of this information. So we're going to need to know if MetaMask is working. The chain ID needs to be there, the fee, the gas. I don't think we need the memo. We don't need a to field. We don't need an amount. We're going to need the account info, and the per pub key. And I'm going to go ahead and just make a simple rest of the function here so that we actually have something we can render and test it out real quick. And so we're going to need to connect MetaMask, verify the pub key, display that information. But we're not going to need this to field. We're not going to need the amount. We will need a fee. And then I think I also deleted the memo. Okay, so this should work for us for the moment. Let's go ahead and go over to our website and see the changes. I've got an error here. It's unexpected token in the submit message liquefy. Okay. So it's this comment it's not expecting. So I need to close my component, reformat the whole thing. Hopefully this works now. Default chain is not defined. Okay. So I've got a few issues in my code here. Let's see, where am I using default chain? There we go. So I need to copy these definitions from below. I'm going to just go ahead and copy the entire file, or the entire contents, but we're not going to be using all of that, and just put it outside of the component. And that should get us rendering again. Nope, on connect MetaMask. I think we don't have the right functions defined. Okay, so I can copy those as well. So we're going to need to fetch the account info. We're going to need to verify the public key. We're going to need to connect to MetaMask, and we're also going to submit. Let's copy those real quick, put them in the component. And now we have some references to things we don't need. All right, we're not going to be using that. We're not going to be using the to field, nor amount. And hopefully now it's working. Yeah. Okay. So what you should see now is 2 tabs. So if they both start the same way, so clicking on them doesn't really appear different, but we've got the ability to connect to MetaMask and verify the public key. And then this would break if I hit submit TX because we haven't handled that. So let's jump over real quick to the actual transaction that we're going to try and implement here, which is in Altheajs, the transactions package. And then we're similar to the bank one, we're going to jump down to the micro-TX module and the liquefy file. So we've got this message liquefy that we want to submit. This is actually what will turn a account that's part of like an automated service. You know, for example, on the Althea network, we have a lot of routers. Those are going to be liquefiable. But if you were going to have like a device that was like a vending machine or anything that would collect payments or just pay users, like other members of the network for some service, you could also liquefy that here and control it. So this is going to basically turn the account into infrastructure so that you can manage it more effectively, and then also get a lot of convenient features like automatic balance forwarding to an account that you set up. So what we're going to do is we're going to use this message liquefy params, and then also similar to earlier, create TX message liquefy. So we're just going to be setting up the context and the params. The params just takes sender. That's very simple. Everything else should look the same. So we're going to go in here and we're just going to really quickly change this. So the create EIP 712 params function is going to be the main thing that we need to fix. And I think that we don't even need to specify any additional values, like how we deleted the to field in the memo and stuff. We don't need to specify another account because we're going to be liquefying the account that submits the transaction. So we're going to go down here and we're going to create a different sort of params. And so we're going to need the account, and it's going to be the Althea 1 account. So we have that above here in the account address field. And we need to change the type of transaction we're going to create. And I believe it got auto imported for us. I'm just going to delete the old one that we're not using anymore. And with that, we might be good to go. I'm just going to check on the other things. So we've got the function call to create the context and the transaction for us. And then we're going to be signing that with MetaMask. This should take any sort of transaction, so we don't need to change anything here. And then when we go to broadcast it, we're just broadcasting the signed transaction, so we're not going to be doing anything here. So I think this should just work for us. So let's go ahead and do a test run. Fingers crossed. Going to refresh first since I changed the logic, and I'm not sure how React handles that. But we're going to switch over to the liquefy tab, connect, verify the public key, sign that. I'm going to open the console for this since I didn't set it up to display. And we're going to go ahead and submit this transaction. And if it works, that'll be a first because this is a live demo. And as we know, live demos never work the first time. So let's, fingers crossed. Here we've got the message liquefy and the sender. And this is the third message I've ever sent from this account. So let's give it a shot. Oh, it's generating the wrong transaction type. Let's see here. Is this something that I can control? we're using the legacy amino. So I don't know. I don't know if I can fix this. This might be a library issue. So let's jump in real quick here and see what's going on. Oh, I know the issue. The testnet doesn't have the updated code that I run in my local. So what I'm going to go ahead and do is here I'm going to do Althea start, run a local blockchain. Right, this is a hack that you get to do if you are the developer of the blockchain. I have an updated version of the code on my local machine that doesn't exist on the testnet. And so this fixes a bug with submitting this specific type of transaction. So I need to go in here and point this to localhost. And then in MetaMask, I need to switch from the live testnet to the local testnet. All right, here you can see I have a different balance entirely because it's a completely different blockchain, but the account is set up. And so I'm going to go ahead and refresh so that now it's pointing to localhost. I'm going to connect. The account doesn't exist. Let's see, do I have another account that I can use? Nope, I don't think so. All right, well, I'm not going to be able to get this to work, but it is an issue with the blockchain itself. So that account doesn't exist, and I don't have the ability to set it up just yet. So that's not going to work for us, but this code would work if the blockchain was updated. So you'll just have to take my word for it, and when we update the blockchain with this, everything should work out for us. But for now, that's going to be the end of the demo. And like I called it, it wasn't going to work because it's a live demo. But the code should work for any sort of message that you want to submit to the blockchain. All you need to do is go into the Altheajs transactions package and look in this messages folder. It's got every single message that you can submit to the blockchain broken down by the actual module that uses it. And so that's how you would get Cosmos transactions to be handled on the blockchain. On the other hand, if you're just going to be submitting regular Ethereum transactions, for example, to a contract that's deployed on Althea L1, you can do the traditional Ethereum transaction submission. And there's plenty of documentation, plenty of tutorials out there for that. You would just have to identify the correct transaction and the correct contract address. And you would send that to the 8545 port on Althea L1, and it would work as normal for you. But this entire thing is how you interact with the Cosmos side of the blockchain using MetaMask. And so hopefully that is helpful. If we have any other questions, I'd be happy to answer them now. But for now, I'm going to stop sharing my screen, and I think that's going to be it for the technical part of this workshop.
Awesome. Really great work, Christian. Let's see. Do we have any questions from the audience before we wrap up?
And like I mentioned, if you have any technical questions about Altheajs or anything involving the blockchain, especially when it comes to these kind of gotchas, like the blockchain doesn't have the capacity to support that message type, you know, I'm the person you should talk to about that. Just go ahead and @ me in Discord, and you can also @ Justin for a lot of these questions, and one of us will get back to you.
Cool. So it doesn't look like we have any technical questions right now. So let's go ahead and wrap this up with a closing note about the Althea testnet. So the testnet is currently active in addition to the to a hackathon which is taking place on that testnet, which you can find on here. Let me make sure I have it right before I speak the URL. Let's see. You can find that at DoraHacks, DoraHacks.io. And we're really excited about a lot of the interesting projects that are building on Althea 1. And we're especially excited to hopefully launch soon and get and start moving all of Hawk Networks Inc. internet customers over to a more reliable blockchain with interesting tools and interesting properties like this, like all of this liquefaction code and liquid infrastructure code, which will make a lot of new things possible, as well as simplify day-to-day management for our operations quite a bit. Any closing thoughts, Christian?
No, I just wanted to say thank you for watching the workshop, and I hope that you build some really interesting projects with it. If you have anything involving a website, go ahead and at me what you're doing if you're having any difficulty. Very exciting space to be working in, and I'm really happy that you all are participating in the hackathon. So just happy hacking.
Cool. Thanks, everybody. See you soon.
Thank you.